It's time for Security Now. Steve Gibson is here. We got a lot to talk about, including the changes Apple's making to Safari and why they're really good for your privacy, and a little insider action on the certificate thing. It's all coming up next on Security Now.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Security Now is provided by CacheFly at CacheFly.com. This is Security Now with Steve Gibson, episode 666, recorded Tuesday, June 5th, 2018, Certificate Transparency. Security Now is brought to you by FreshBooks, the ridiculously easy-to-use cloud accounting software helping small business owners thrive. Try it free for 30 days at freshbooks.com/securitynow. And by Rocket Mortgage from Quicken Loans. Home plays a big role in your life. That's why Quicken Loans created Rocket Mortgage. It lets you apply simply and understand the entire mortgage process fully, so you can be confident you're getting the right mortgage for you. Get started at rocketmortgage.com/securitynow. And by IT Pro TV, flexible and entertaining training for your IT career. Visit itpro.tv/securitynow and use the code SN30 to get a free 7-day trial and 30% off a monthly membership for the lifetime of your active subscription. It's time for Security Now, the show where we protect you online, thanks to the good auspices of this feller right here, Mr. Stephen Tiberius Gibson of GRC.com.
Leo.
Yo, what's happening, dude?
Well, we have made it to episode 666.
Oh, no!
So, as I tease our listeners, we are 2/3 of the way through the lifetime of this podcast because all of my systems only support 3 digits. So we can go and...
We'll talk about this in 333 podcasts.
That's right. But until then, an event that happened a couple days ago, Chrome 67, caused me to think, we should do an introduction to something that we have never yet introduced, and that is certificate transparency. This is an initiative that Google rather quietly initiated like 4 years ago. My favorite certificate authority, of course, we all know DigiCert, was the first CA on board. And through the podcast, through the 666 previous weeks that our listeners have endured, we have often talked about, because it's a big issue for security, the problems with the CA system, with the certificate authority system, certificates being misissued, them being maliciously issued, and so forth. So certificate transparency is a publicly posted and publicly auditable log of certificates. And it very elegantly, and the other thing, of course, that I annoyed Google with was the revocation problem. The fact that, as we know, certificate revocation really never has worked. So this is an interesting and way more present solution than anyone has really been aware of. And I've touched on it from time to time. The reason it was brought to mind for me for this week is that Chrome 67 just dropped and removed a previous sort of attempt at solving this problem with something called HPKP, HTTP public key pinning. Well, that just got removed from Chrome, and that doesn't happen very often. So we'll talk about that. Lots of other stuff too. We've got some nice privacy advancing news that, as you know, because you were present during yesterday's WWDC presentation, where Craig Federighi, not I want to make sure I don't say Ferengi.
No, he's got better ears than that. Yeah.
That's right.
Well, his hair, I don't know.
Well, they were we want to talk a little bit about Apple's movement in the privacy direction. Also, a little bit of follow-up on last week's VPNFilter takedown by the FBI and them asking everybody to reboot their routers and what's been going on since. The picture of the week involves an extremely clever web browser cross-site information leakage side channel attack. In other words, it's we've talked often about the same origin policy and how rigorous browsers are to separate what can be run, what code or images can be displayed from what site and so forth. This is a way of breaking the iframe sandbox that is just so cool that, of course, we had to talk about it. And the browsers have scrambled in order to fix this. We also have we're going to talk a little bit about quantum crypto today, which it's also been one of those things kind of lurking in the wings. Microsoft Research, the research branch of Microsoft, has forked the OpenVPN project and developed a OpenVPN version which is quantum safe, so they believe. Also, at the same time, the front office of Microsoft dropped the ball on a significantly serious zero-day remote execution vulnerability. Hopefully next Tuesday, they're going to, because they're scrambling right now, they were given 120 days. It's like, whoops, sorry, the clock expired. So we'll talk about that. We've got Valve finally patching a long-standing and it had been horrifyingly potent remote code execution vulnerability that has existed in all 15 million instances of the Valve, the Steam client for like 10 years. We're going to revisit the Redis caching servers, which continue to be in serious trouble. We have a little more information about that. A previously patched 0-day in IE continuing to find victims. And then, as I mentioned, we'll talk about Chrome 67, their removal of HPKP, what that means, do a little bit of housekeeping, miscellany, and then talk about certificate transparency, which is, I think, without question, where we're heading in the future. So, yes. Another information-packed week.
Yes. All right, Steve, let me start us off on the first of our 3 fine sponsors for this week. Numero uno, FreshBooks. This is great for anybody who's these are all the companies by the way, we love these companies that support us and make this show possible. FreshBooks supports freelancers and small businesses of all kinds, including me. I used FreshBooks when they first started some years ago. That was when I was going up to Canada to do Call for Help and later the lab with Leo. And I had to invoice the company. I had to send them expenses, all of that stuff. And I hated doing it. And anybody who has to do invoices knows it's no fun. End of the month, you fire up Word and Excel. And this one I had to convert to Canadian currency. And I had lots of expense receipts, stuffed in my pockets. It was just a pain. FreshBooks saved my life. First of all, they make it easy to do the invoices. You do it all. It's web-based. They look professional. They're great. Their autofill. They have an app. They still do, iOS or Android. You can take pictures of the receipts, get them right into the invoice. And there's interesting things happening. You're entering in your accounts receivable. You're entering in your expenses. When the invoice gets paid, you get that information in there. And by the way, they get paid faster. A lot faster, because as soon as you start using FreshBooks, you can start taking credit card payments. And the invoice says, pay Leo. It turns out clients hate bill paying. In fact, you know this because you're both, right? Hate bill paying as much as they hate making invoices. They're both bad. So make it easy for your client to pay you. On average, FreshBooks users get paid twice as fast. And that makes a big difference in your cash flow. So you've got receivables, you got payables, you got payments, you got expenses. Guess what? without doing anything more. You're essentially doing your bookkeeping. They do it for you. In fact, they'll even automatically connect to your bank account and update expenses daily. So you can import them in bulk, take a picture of receipt, upload it, let them get the information from the bank account. You can use, you get all sorts of reports, but you get the tax reports you need when tax time comes next year. It's going to be much, much easier. You can see, and this is something a lot of small businesses don't know, whether you're making a profit right now or not. A lot of times you don't know that till tax time. Did I make money this year? You can have teams too, manage team member rates and add team members as in different levels as business partner or basic employee or contractor, giving them different permissions. They are always adding new features because it's a web app. Like I mentioned a couple of months ago, they added the ability to create proposals with rich text content and images, and you can have e-signatures from your clients accepting the proposals. There's a revenue streams graph now, so you know exactly where your invoice and non-invoice revenue is coming from, online sales, ads, other non-invoice revenue. You can accurately plan for growth. You can make informed decisions about how to diversify. This is like big business accounting information, but it's automatic. You don't have to, it just happens. And I love it that if you don't get paid on time, you can automatically send little reminders to the clients, as gentle or rough as you need to be. You can see what was sent, what was paid, what's overdue, and whether or not they've viewed the invoice. Your clients you can import them from a CSV file, just a few clicks, so you don't have to start typing in a lot of stuff. They have now payment into Microsoft Outlook payments, integration into Microsoft Outlook payments, so users can view and pay FreshBooks invoices on any device. And if your credit card's registered with Outlook payments, boom, just like that. No wonder 10 million people now. I think I was one of the first. 10 million people now use FreshBooks to painlessly send invoices, track time, to capture expenses, and then to get back to doing what you love. Because you didn't get in this business to do invoices. Try FreshBooks free 30 days right now, free at freshbooks.com/securitynow. Use SecurityNow in the How Did You Hear About Us section, and that would help both Steve and me. That's freshbooks.com/securitynow. We thank them so much for their support of the Security Now program, featuring this guy right here.
So our picture of the week relates to a story that we'll be getting to a few stories from now. But it's just so pretty that I wanted to put it up there. For those who are listening, it just shows a stack of layers that the bottom one says cross origin iframe, and then there's a target pixel sort of focused on that iframe, and then a bunch of layers on top of it labeled difference, lighten, difference, color, dodge, multiply, and then some transparency layers labeled saturation. And the point is that this is a multi-layer, many-layer stack which web browsers, contemporary web browsers that support an advanced feature of CSS3, which both Mozilla and Chrome do because they share a common graphics library in their foundations, which does this. This turns out to have been leveraged into what is essentially a side channel leak in browsers that, for example, allows an unwitting person who visits a web page that does this to them to have, for example, their Facebook profile photo and their name divulged, even though it's explicitly against all of the browser rules for that to happen. So the way this works is very cool, and we'll be talking about it in a minute, but I wanted to put the picture up at the top because it's a pretty picture. So since it just happened, I just thought I would mention that Apple is continuing, as they announced at the Worldwide Developers Conference yesterday morning, to move, in the direction they've been going for some time, stating that one of the things that they're selling, one of the things their customers want, is increased privacy. And so one thing that they've done in Safari, they announced Mac OS Mojave as the next major MacBook OS and iOS 12. I did note somewhere in just digging around in the last day that apparently that an iPhone 6S, which is now an old iPhone, would do something a lot faster under iOS 12. I don't remember what it was, but it was like
everything. Oh no, it's a big change.
Oh, so it's a big
overall improvement. Yeah, 70% improvement
yay.
in opening the camera times, a double improvement in apps. I want to say app switching. 50%, big improvement, and people have already reported with the beta that they're seeing this. Yeah.
Oh,
They're really focused on performance.
Whew, nice. So that's good. In Safari, for both platforms, both Mac OS and iOS, we've talked a lot about fingerprinting, and that there's that Panopticlick site which makes it, is I think the IETF sponsors it, and that's that site which has experimented with and shows a user when you go to Panopticlick how unique the fingerprint is that results from hashing a bunch of the browser headers. And we've talked about this through the years, that, for example, the user agent header will tell you not only what device, what like browser you're using, but like what library of ActiveX, and they're like version numbers, 3.29.724.0326, and somebody else will have .0327. And so their browser headers hash to a different fingerprint than yours. And when you combine that, like all the version numbers of the plugins with, in some cases, the browsers will enumerate which fonts they have, which font libraries they have installed, so that a web server could know what fonts are available to be rendered in the browser. There's just, the browser headers have exploded over the years with all this extra information, which with surprising accuracy can without the user doing anything, allow sites that want to track them to lock onto them with this fingerprint. So one of the things that we learned yesterday is that Safari is going to deliberately take action to thwart that kind of fingerprinting. So that's good. And it's funny too, because in thinking about this, I realized how easy it is to confuse tracking with advertising. I think that the two get mixed up a lot together, because when you start talking about blocking tracking, there's this, but wait a minute, how are sites going to survive? And it's like, wait a minute, advertising and tracking are separate things. You can still have ads if you're not being tracked around the internet. So, there's tracking blocking is different than ad blocking. And it seems that what we're seeing is a pushback, well, obviously against both, but there is an understanding, I think, and some websites are taking action on this, as we've talked about, where if they see you're running an ad blocker, they can say, and I'm encountering that from time to time because I run uBlock Origin, and I'll often say, oh yeah, okay, fine, and and allow ads on a site that I want to support. Now that sort of follows into the other feature that I'm going to be interested to experience. And Leo, I don't know if you've talked to anybody who's using this next Safari, but what they showed us yesterday during the opening, what's new at the WWDC, was a pop-up which you would get saying that, asking for permission for another site to track you on the site you're visiting. And
that's for like a Facebook like button. So that means on the page that you're on, there's JavaScript that then sends data to a third page. It's like third-party cookies, except it's not. It's using, I presume, JavaScript to do that, right?
Well, actually, it could be using first-party cookies because when you have an object like a like button,
it looks like it's coming from inside the house.
Exactly. It actually is sourced by Facebook, so when you're logged into Facebook, as you
but the
move
browser
around the
knows
net,
where. So the thing is, the browser knows what page you're ostensibly on, and then
Yes.
sees a link back to Facebook, and that's when it says, "Oh."
And so that's what I'm confused about, because they're calling this Intelligent Tracking Prevention 2.0.
Well, there's two things they're doing. So there's that, and then it looks like they're blocking super cookies. You know that?
Well, okay, so that's the browser fingerprint I was just talking about.
Yeah,
right?
yeah. So I think those are separate.
They are.
Yeah.
And so what Craig said, for our listeners who didn't see this, he showed a Safari page with a pop-up notification reading, "Do you want to allow Facebook.com to use cookies and website data while browsing?" And then wherever it was you were. And in their example, it was blabbermouth.net. And so here's the problem, Leo. Like, there's nowhere you go today that doesn't have like all this third-party crap loaded onto the page. So, like I said, I'm going to be really interested to see what they're doing. I mean, are they going to I can't imagine they're going to single out Facebook.
No, although this was
Google.
Intended to single out Facebook and Google in the announcement.
Yeah.
I mean, that was very clear. It was a shot to the Facebook and Google. But yeah, I mean, I guess they could treat any call to a third-party site like a third-party cookie, right?
But you'd be buried in
avalanche.
permission dialogues. Yeah. It's freaky. But on this second page of the show notes is my own chart from my own site that has always stood out in my mind. And this, years ago, their browsers were not handling cookies correctly. So I created this cookie forensics system.
Yeah.
But what stands out among all the browsers is Safari. Look at the Safari bar, because Apple has always blocked third-party cookies by default, and they're the only browser to do so. And it's always impressed me that here among all the browsers, and obviously this chart is dated now. We've still got FF version, Firefox version 2, version 3, and version 4. I haven't messed with this for a long time, but there is like this little tiny bar of Safari. Now, this protection fails, as I was just mentioning, when you start hosting content by like active content from other sources, because then then you got JavaScript and other technologies present. But still, Apple has in fact has a long history of blocking this kind of action. So I just wanted to share with our listeners that Apple is continuing to move forward. But
you do raise an interesting point. It's not beyond Apple to kind of trumpet something like this, but do something less aggressive under the hood. So
I don't know how it could possibly work.
They can't do this. Yeah,
it's just going to
be like no script.
Nothing would work.
Nothing would work. Yeah.
And maybe there's like a don't ask me again sort of thing, where it's like, so I mean, that's the only way I can imagine it is you immediately start using the new version. It says, and so like it's not a per site question, unless maybe you want it to be, but it's like no and don't ever ask me again sort of option. I just don't know. It'd be really interesting to see how this plays out, because boy, these days there's nowhere you go that doesn't have a third-party stuff. So either they're explicitly looking for particular domains. Of course, then Google and Facebook would cry foul, saying, "Hey, you're singling us out for abuse compared to everybody else." And it's going to be really interesting to see how this happens. I don't know.
Yeah.
So, as we know, last week's podcast was VPNFilter, talking about this collection of of routers that had known vulnerabilities being exploited by, we believe, actually there's strong forensic evidence to suggest that it is the apt28 group, aka Fancy Bear, which is operating out of Russia, largely targeting the Ukraine. Since the takedown of this large botnet of composed of all these routers, and remember that the toknowall.com domain was taken away from VeriSign's control over to the FBI, that were then using it in order to monitor the botnet and to get command and control away from those who had it. What's happened is, since that time, the Ukrainian IP space has been actively scanned, and a number of security firms, JASK and Gray Noise Intelligence, have both been watching the net in the wake of this takedown, and have seen, let's see, 1, 2, 3, 4, 5, 6, 7, 8 IPs scanning port 2000 of the Ukrainian IP space. Port 2000 is the one that the MikroTik routers unfortunately have open, that allows them to be taken over. And so this strengthens this sense that existed before, that this was from Russia and aimed at Ukraine networking devices, and that this is still an active campaign even post commandeering of the command and control server. And what's odd is that one of the IPs, 9.110.0.5, well, 9. anything, the whole 9 network is owned by IBM and always has been. So I presume some obscure machine somewhere, I mean, it's, not at IBM central headquarters, just some random machine in somewhere on the IBM network at that IP, probably, I mean, unless it's a security scan, which is certainly possible, is probably got some malware in it and is scanning for Ukraine-based routers. Also, there's 2 IPs closely related to each other in Russia, 2 in Brazil, 1 somewhere in the U.S. Oh, no, actually 3 in Russia, 1 in the U.S. and 1 in Switzerland. So it looks like there are, a few systems without looking to see what they're all about. It's hard to know if they're malicious or not. But, I think what we're going to see, and we'll be talking about another class of attacks here in half an hour or so. These internet exposed devices are going to be a constant source of trouble, and I don't know how they get fixed over time. Okay, so Leo, this incredibly clever hack, obscure as this is, it was independently discovered by security researchers who didn't know about each other. And it's, the word I've used in the past for something like this is sublime. In CSS3, the latest standard of cascading style sheets for our browsers, as we know, HTML5 and CSS3 have just piled features onto browsers. I mean, they are rapidly becoming full capable citizens on the desktop, and in fact are beginning to host full-blown applications as they become faster, and the script that they're able to run is having every feature that you would want from a desktop app. Now, unfortunately, some of the press didn't get this right. Ars Technica ran with the headline "Exposed" in all caps. Chrome and Firefox leaks let sites steal visitors' Facebook names, profile pics, etc. Okay, well, yes, but it's really not the fault of Chrome and Firefox. As we've talked about, one of the core security requirements for browsers is the same origin policy, the enforcement of the same origin policy. The idea that if we're going to have web pages with content from multiple sources, as I was mentioning just a minute ago, virtually all, except GRC's web pages, virtually all web pages have stuff coming from everywhere else, all kinds of other places. So sandboxing those is crucial because, for example, any web page that has ads is now using an ad network to fill in the rectangular space on the ad on the web page where the ad network will put up an ad. So that is inherently a third-party source. For security, since the server hosting the web page is giving the user's browser an ad network URL saying fill this frame in with whatever you want, it is crucial that be contained, that frame be sandboxed and has no access to other frames on the page or the page itself. Otherwise, we would have no security. Well, for example, that page has a persistent cookie, which is how the user is logged in. So you absolutely don't want third-party content hosted on that page to be able to access, for example, the cookie of the hosting page, or you'd have a problem like we did once upon a time with Firesheep before HTTPS was in place virtually everywhere that it mattered, where session cookies were not being secured. So containment is crucial. Therefore, the idea that some researchers broke containment is significant, and that's what happened. And they did so in just the coolest way. What they realized was that the CSS3 feature called mixed blend mode is not constant time. So we've talked, for example, about mistakes in ciphers in the past, like, for example, AES did not make the mistake because we knew about the mistakes by the time AES was being designed. But I've in explaining this in the past, I've explained that you don't want secrets to cause, for example, the bits of a key of a cipher to cause the decryption to take different amounts of time depending upon those bits. So what you want is you want a cipher that is constant time relative to the bits of its key. Because if you don't have that and you're able to time how long decryption takes, you can start inferring what the key's bits are from that. And so that's a classic example of side channel leakage. Another instance is constant power. You don't want the power consumed to be a function of any secrets. So what several independent researchers simultaneously realized, and there had been some related work involving SVG, the scalable vector graphics system. So they've been sniffing around this before, and some other work designed or other work in this area. They realized that this mixed blend mode might not be constant time, and in fact, it had not been. So the idea with mixed blend mode is it's very much like applying filters to graphics. And in fact, Leo, there's a css-tricks.com site. I have a link here in the show notes on the basic CSS blend modes that shows you example where, for example, you have a black and white photo of a building and then a red rectangle, and you merge those two together, and it just sort of gives you a red tint on the black and white photo. So, so the idea is that in our browser, we are now doing compositing, image compositing of addition, subtraction, multiplication, saturation, whitening, lightening, darkening, and so forth, all kinds of different features. And that requires math on the pixels. Individual pixels that line up through these layers have math operations performed on them. And if it's just addition, subtraction, and multiplication, then those are probably constant time. But if you have something like saturation, where you might add 2 pixels and you need to check to see if the sum overflows, then you need to clamp the pixel at maximum luminosity rather than allowing it to overflow. So suddenly you have a code path that depends upon the brightness of the pixels. And so what these guys did, and they've done a proof of concept, they arranged to create a code where an unwitting web browsing person would go to a website and in 20 seconds could have their Facebook name obtained by that site that they're visiting. And that's done by the site having an iframe to facebook.com. That will, since the user has a presence at Facebook, if you go to facebook.com, it brings up the user's page in the iframe. And they hide this under another image, and then they're able to scan the iframe graphics with their own scanning pixel, measuring the length of time required to perform this compositing math as this pixel scans, and thus infer from the length of time it takes the color of the pixel in the iframe of a foreign site. And so it's just an amazing hack. It turns out that this was disclosed responsibly some time ago, and that there is a graphics library that Facebook and Google share. It's called SKIA, and it's an open source graphics library. Google purchased the company Skia Inc. some years ago, and so brought them into the Google fold, and then made the whole thing open sourced it under the new OpenBSD license, I think, the BSD free software license. When they fixed the problem, in order to basically focus on this layer compositing problem, they also, in the process, not only made it constant in time, thereby eliminating the ability to acquire any information based on how long things take, which you have to do if you're going to have security, but across the board, it is way faster than it was before. So basically, they focused on it, made a constant time and constant power graphics processing pipeline, and at the same time, I've got the numbers in the show notes. It looks like in some cases like better than a factor of 3 faster. So like in less than a third the time it took before, they were able to do that. But anyway, just another example of how, despite our best efforts to keep things secure, when we add all kinds of new features to existing technology, it's because there's an exponential effect of every feature interacting with every other feature, when you add a couple new features, suddenly the possible number of interactions among them just explodes. And so we have a whole bunch of new HTML5 features, a whole bunch of new CSS3 features. And here's an example of where you would never have thought that what you're seeing in an iframe could somehow be leaked into code running on the page that hosts the iframe. Yet that has just been pulled off. So I salute the cleverness of these attackers. These security researchers who thwarted what, I mean, it's not like it's a huge problem, but you can imagine some situations where you're logged onto a site and there is some sensitive information that the site displays when that's the condition you're in, and this would have allowed that displayed information to leak onto a page that you're visiting. So, I mean, it does break the security guarantee, which is so important for web browsing as we go forward. It's not a fast attack. It takes time to essentially measure the rendering time of individual pixels, but they demonstrated the recovery of the person's name in Facebook given about 20 seconds of just sitting there staring at a page doing other things, and this thing's happening in the background.
Would you have to be able to watch their browse? I mean, how would you get the information?
So you as a user, an innocent user, would just go to some site, and you would have no idea that this was going on in the background.
The site would have to be malicious.
Correct.
And it could measure it because, of course, it's loading it. Okay.
Correct. Yep. Amazing. So OpenVPN is, to this day, my favorite virtual private network platform. It's what I use for connecting to GRC. It's what I use between sites. I mean, the OpenVPN guys just nailed this problem. It supports UDP and TCP protocols. It's always hosting the latest OpenSSL library, so it's up to date on all of its crypto. It's the one. And so if you were a user wanting a VPN, what you would look for would be an OpenVPN host, but OpenVPN is what you want to be using. You don't want, Tom and Jerry's VPN. This problem has been solved with OpenVPN. Except, what about quantum crypto? As we know, there's, cryptography is potentially endangered by the specter of quantum computing, because it has been known now for some time that the hard problems upon which some classes of our cryptography depend may fall apart. They may no longer be hard problems if we finally have quantum computers that are more than just at the toy scale. Right now, quantum computing is still a toy, but that's the way all this stuff starts. Computers were once toys. Now they're certainly not. So way back in 1994, a mathematician named Peter Shor, whose algorithm bears his name, Shor's algorithm, showed that if a theoretical quantum computer existed with the set of properties we expect them to have, that integer factorization was no longer hard. So, as we know, for example, classic RSA public key crypto, where we take two very large primes and we multiply them, and that creates the public key, and that the reason we're able to give it away and make it public is that even though it's there for everyone to see, it is composed of the multiplication of 2 primes, and nobody has figured out how to unmultiply them, how to factor their product back into the individual. So one of those primes is the private key, and it's also sitting there out in public view, except since it's been multiplied by another prime, you don't know where it is. You can't find it in the product of the two. Yet the cleverness of crypto allows you to use the properties of the private key without knowing what it is. So that's RSA style public key crypto. It utterly, all the public keys floating around out there contain the private key, but it's only the fact that we don't know how to crack them back apart that makes it safe. So Peter Shor showed us that, give me a quantum computer and I'll crack all those public keys back into their 2 components, and it's game over for RSA style public key crypto. So that's a little worrisome for cryptographers. Elliptic curve crypto in its current form is similarly vulnerable. So it's not like ECC crypto isn't in similar trouble. Shor's algorithm can also slice right through the so-called discrete log problem, which is what protects elliptic curves point multiplication, which is the hard problem that elliptic curve crypto offers. Now, what's interesting is that it's that public key crypto, whether it's RSA or elliptic curve, where the vulnerability exists. Our symmetric cipher, like AES, it is believed to be fine. Everyone wants to double the key from like 128 bits to 256, but AES with a 256-bit key is currently believed to be plenty strong, even in the face of quantum computing. And the same is true for our hash functions. SHA-2 with a 256, so SHA-256 or the SHA-3 functions, which are, have now been settled on and they're just sort of like on the back burner waiting for us to need them. They don't have to change post-quantum. Yet the public key components they're based on difficulty. So that's why we talk about an RSA key length of 1024 bits or 2048 or 4096. The problem is that's a lot of bits, because the thing that they're trying to make hard, which is in the case of RSA prime factorization, is not that difficult. So Microsoft has the Microsoft Research Group have forked OpenVPN and have a running, operating, you can download it and install it today if you want, post-quantum OpenVPN implementation. They have 3 different algorithms, one called Frodo, which is a key exchange protocol based on what they call the learning with errors problem. Then there's one called Psyche, S-I-K-E, which is a key exchange protocol based on what's known as super singular isogeny Diffie-Hellman. And I imagine probably before we get to episode 999, I will be talking about what that is.
Ooh, that'd be interesting.
Yes. And then Picnic, which is a signature algorithm using symmetric key primitives and non-interactive zero-knowledge proofs. And again, I imagine we'll be talking about that in the future. I won't get into it in any more detail except to note that those things exist and that we don't need them yet. The reason cryptographers are thinking about post-quantum crypto is not that we're in any obvious danger, but that we now understand these things take time to develop and prove, and we would like to have them ready, much like we have SHA-3. That's a whole nother next generation of of secure hashes just sort of sitting there on the back burner. We'd like to have well researched and tested algorithms which are resistant to the things that we think quantum computers will get good at doing when quantum computers get good at doing anything. And right now, they're just toys, but everybody's excited about them. And so we know that, as famously, these things are always going to be getting better. Quantum computing is going to be no exception to that, I think. So anyway, it's called PQ Crypto, Post Quantum Crypto. I have a link in the show notes for anyone who's interested. It's up on GitHub. And by the way, I'm sure, I don't know if you've talked about it yet, Leo, but Microsoft bought GitHub for $7.5 billion.
Yes, they did.
So they are GitHub's new parent.
This is upsetting to a lot of open source folks, but
does and GitLab has seen a huge spike of incoming projects moving from GitHub to GitLab. There are other people who have no problem with Microsoft being a benefactor for GitHub, and in fact, the incoming Microsoft CEO of GitHub has said, well, of course, he's Microsoft, so he would. But that Microsoft will not be changing anything.
Oh, yeah.
Nothing happens.
I've heard that before.
I know. Yeah.
GitLab is not much different, frankly, than GitHub. It's going to have the same issues and could easily be acquired by somebody. But the problem is I use a private Git. But if you want to do what, like this project you were mentioning, if you want to have your code be public for people to download, look at, and contribute to, you need a public-facing server to do that. And I think GitLab might, in fact, just... SourceForge has also said, hey, we're not as bad as we used to be. Come on over to SourceForge.
Oh, God, it's a sewer, Leo. Have you seen...
I think they're maybe not as bad. I don't know. It was a sewer. You're right.
Whenever I'm like looking for something and I have to go get it from SourceForge, just like, oh, really?
SourceForge used to be the place, and actually GitHub kind of replaced SourceForge. And
Yeah.
I'll be curious. I mean, Microsoft loves open source.
They are loving it more every day.
More than they did.
Yes. Yeah.
I don't know. You can run your own GitLab instance, so that may be what people end up doing is just hosting it themselves.
Yeah.
In fact, GitLab's looking at federating, which would really be cool. Then you could have multiple GitLab sources, including I could run my own GitLab server, which I do, and then federate it so that you could go to gitlab.com and see all of them. That would be cool.
And that solves the problem of fragmentation.
Exactly.
Where yes, and that's what's been so nice about GitHub is it was a one-stop shopping for all of these different projects.
There were issues with GitHub, and frankly, they were losing money, and that was what really happened. They were struggling. Yeah.
We're 51 minutes in. I think we should take break number 2, and then we will continue.
Thank you, Mr. Steve Gibson. Our show today brought to you by Rocket Mortgage. The folks at Quicken Loans, #1 lender in the country for home loans. #1 in a couple of ways. #1 in volume, yes. They just took that crown, actually, late last year. But also #1 in your hearts, according to J.D. Power. And the customer satisfaction index, they're #1 in mortgage origination for the last 8 years, #1 in mortgage servicing for the last 4 years. That's good. And I think they're going to be #1 for a long time to come because they've created something very awesome called Rocket Mortgage. So this is from Quicken Loans. So it's backed by the best lender, but it is completely online. And for people like me, that makes me happy. I don't want to go to a bank. I don't want to have to go to the attic and find paperwork. I don't want to have to call the bank and say, do you have my statements from 2012? And that's actually what we literally had to do when we bought our last house, Lisa and I, in 2013. We were faxing them stuff for months, almost 2 months. It was the big bank, everybody, the bank, which interestingly used to be the #1 lender and now isn't. Wonder why. Quicken Loans created Rocket Mortgage so that you could do all of this online. You could instead of taking 2 months or even 2 weeks or 2 days, it takes 10 minutes. Literally, around 10 minutes or less. Here's the deal. Go to rocketmortgage.com/security now. Sign up now. You'll be ready to go. The way it works, you answer a few simple questions. You already know. You don't have to go to the attic to find out. Things like your home address, birth date. And then they go out. They have trusted partners with all the financial institutions. So with your permission, they go out and they get the information they need. And then they crunch the numbers. That takes no time because computers. Right? Income, assets, and credit, they chew it all up, and they spit out the right home loan options for which you qualify. You choose the rate, the term, the down payment, and it's done. So fast you could be an open house. You say, honey, we should buy this. This is a great house. What a price. I can't believe they're... Who knew? And then, well, are we good for it? I don't know. Let me go. You go to rocketmortgage.com/security now. You're looking at the kitchen. You go, you fill out the form. You're looking at the bedroom. You get to the living. By the time you're at the hot tub in the back, you can say, oh, we're approved, and show the realtor. Look, it says we're approved. That's called applying simply, understanding fully, mortgaging confidently. Rocketmortgage.com/security now. Equal housing lender, licensed in all 50 states, and MLSconsumeraccess.org number 3030. Rocketmortgage.com/security now. And we thank them for their support of Security Now. I have lost control of my keys. I'm pressing a button. There we go.
Yay, I'm back.
Yay, he's back, ladies and gentlemen. More Steve Gibson. Oops, that's not you. That's you.
Oh, is that like some Fibonacci thing?
It was a Sierpinski triangle, actually. I'm learning how to... I've been taking a coding course, and this was an exercise in the coding course. See this little tiny recursive function? That's all it takes. Why, it's almost as compact as a Steve Gibson assembly language program.
Very cool.
Now I'm stuck on it. Oh, there we go. Okay, back to you, Steve.
So when 4 months is not enough time to fix a bad bug, back in a little after the middle of January, a researcher, Dmitry Kozlov of Telespace Systems, discovered a significant problem in Microsoft's Windows JavaScript engine. He responsibly disclosed it to Trend Micro's zero-day initiative to start the clock. The ZDI group, the Zero-Day Initiative group, responsibly notified Microsoft on January 23rd and received a same-day acknowledgement from Microsoft. Then a week ago, last Tuesday, May 29th, more than 4 months later, the ZDI group decided to hold Microsoft accountable for not patching this still unpatched serious remote code execution bug which exists in their JavaScript engine. They posted last Tuesday, their post was titled 0 Day Microsoft Windows JavaScript Error Object Use After Free Remote Code Execution Vulnerability. And we've talked about use after free problems, the idea being that in languages which incorporate automatic garbage collection so that the programmer is not required to indicate when they're no longer using an object, the system releases it. But in some cases, and when mistakes are made, you can still have a pointer to the object whose memory has been released. And using that pointer, there are various ways to exploit that in order to get your own code to run, which is what happened here. Their posting says, this vulnerability allows remote attackers to execute arbitrary code on vulnerable installations of Microsoft Windows. And at the moment, that's all of us. User interaction is required, they write, to exploit this vulnerability. And before you go, whew, It turns out that the target must visit a malicious page or open a malicious file. So it's not like somebody can reach out from across the world into any Windows system, but all it takes is going to a website which has leveraged this, which means as soon as the information about this gets loose, it will be actively exploited, because that's what happens with these things. So, in other words, just allowing Microsoft's JavaScript engine to interpret JavaScript code received from a visit to any website.
So that's on Edge or Internet Explorer. That's like Microsoft's browsers. Wow.
Yes. The flaw exists within the handling of error objects in JavaScript, they write, and by performing actions in script, an attacker can cause a pointer to be reused after it has been freed. An attacker can leverage this vulnerability to execute code under the context of the current process. So the timeline of this is interesting. They posted it on their page. On January 23rd, they say ZDI sent the vulnerability report to the vendor, in this case, Microsoft. On the same day, 1/23/2018, the vendor acknowledged and provided a case number. 4/23, so 90 days later, to the day, exactly 90 days later, Microsoft apparently suddenly woke up and said that, so ZDI says here, the vendor replied that they were having difficulty reproducing the issue report without a proof of concept. The next day, on May 24th, ZDI confirmed the proof of concept was sent with the original and sent it again. A week goes by. Now we're at May 1st. The vendor acknowledged receipt of the proof of concept. 7 days later, a week later, on the 8th, Microsoft requested an extension. On the 18th, ZDI replied, quote, "We have verified that we sent the proof of concept with the original. The report will 0-day on May 29th, which was last Tuesday. The good news is there has not been a full disclosure. They have not published anything. So, it's not like they're jumping up and down and saying, sorry, here's all the details. This is a bad bug, apparently. And so, nobody wants to be malicious about this. Hopefully, since this today is which is June 5th, is the first Tuesday of June. Second Tuesday, the 12th, is next Tuesday, and let's hope that this thing gets fixed. So for mitigation, because these guys do know exactly all the details, having had a proof of concept, basically demonstrating remote execution of code on a user's on a recipient, JavaScript recipient's computer. For mitigation, they said, given the nature of the vulnerability, the only salient mitigation strategy is to restrict interaction with the application to trusted files. Essentially, and I somewhere else I saw them saying, don't use IE, Edge, or anything that could run JavaScript. Unfortunately, that's even Microsoft Office. So anyway, we will hopefully next week have this thing fixed. The problem is that in our modern ecosystem, we know that patching, or that the manufacturer patching a problem doesn't fix it universally. There is another instance of a 0-day VB script, so not JScript, which is the last one, but a Visual Basic, a VB script problem in IE and Office that was fixed previously and has now been added to the RIG exploit kit, which is exploiting this, what was a 0-day, even though it's been fixed. So it's been added to this active exploit kit. A A target receives a Microsoft Word document, opens the document, which launches the second stage of the exploit, which is enabled by HTML, an HTML page in the document, which has VBScript, which also has a use after free vulnerability and executes shellcode of the attacker's choice. So that even though that has been patched, it was a couple of months ago, they're still actively exploiting these. And unfortunately, I imagine that this JScript exploit, even if it gets patched, as we hope it will next week, it'll get added to the toolkit, and people who aren't keeping themselves current risk being vulnerable. So for us, listeners of the podcast, the takeaway is do not wait long to update your systems. I know that, with systems taking in some cases a long time to update. As we know, Windows 10 just got better about that. I heard you and Paul talking about this a couple of weeks ago, Leo, the fact that, and we did on this podcast, the fact that Microsoft had moved a lot of the housekeeping needed for these major monthly roll-ups into the background, so the system was much more ready to go when it finally said, okay, now you need to do a reboot so we can bring all of, do the final work and bring the new version of the OS online, right. Making it, a lot easier. And it is possible now, as we know, to schedule these updates for a time when the person is not using the machine. Many people, unfortunately, yes. I was going to say many people, unfortunately, turn their machines off when they're not using them.
Well, and also there's the problem of detecting when you're using the machine. Some people just sit there and look at it for a while. And
yeah,
I've seen machines restart just on their own, while you're sitting there.
Yeah.
It's very frustrating.
Yeah, and in fact, I think I told a story when I was attending that DigiCert conference in Utah, like in November of last year. One of the people there opened their laptop and it just sat there, for an hour. It was unbelievable how long it took, and he's completely offline, couldn't do anything.
I'm updating my Mac right now. I'm stuck. I can't do anything.
Yep, the little spinning roller coaster dots.
No fun.
So, okay, so the good news is Valve immediately patched a worrisome security bug in their Steam client, which had apparently been present for the last decade. Always there.
Wow.
Yeah, and bad. A single packet remote code execution vulnerability. Valve designed their own UDP packet-based connection-oriented protocol, which is fine, but it meant that their own code was receiving UDP packets, and that's also fine. One of the things that can happen to packets on the internet is they can be chopped up into smaller pieces. Years ago on this podcast, when we were talking about how the internet works, I extensively covered this incredible, at the time, conceptual breakthrough with packets and routing, where you would have this loose federation of routers that sort of know what direction packets should be sent to, and that's kind of it. So that packets come in and they say, they look at the destination IP and they say, that came in on interface 4, and interface 2 is the direction that packet wants to go in. And of course, we were talking just last week that BGP failure is an example of what happens when this really lovely system fails us, when routers advertise that they have shorter routes than they really do. The routers that they connect to go, you're a better place to send this packet, even if it's not true. So anyway, the point is that not all router-to-router links are identical. And they're more identical now than they used to be. But, for example, there are some links where you can use larger packets. And a large packet could go a few hops and then hit a link which doesn't support, where the recipient doesn't support large packets. That forces the sender to fragment the packet into multiple smaller ones in order for them to cross this inter-router link that can't do big packets. And there are things called jumbo packets. So at the receiving end, once a packet has been fragmented, it is not reassembled. The designers thought, well, if we reassemble it and then it goes another couple hops, then it has to be fragmented again, then routers are just doing a lot of extra work. So once a packet's broken up into smaller pieces, they stay small until they get to their destination. The mistake that the authors of the Steam UDP protocol made was surprising, but maybe understandable. The first packet, the first UDP packet because fragmentation is possible, it contains both a fragment size and a total datagram length. Normally they're the same, but if the packet has been fragmented, its own size will be smaller than the datagram length. Well, what's missing from the code to check the first packet in a set of fragments is whether that's true. And that missing check to make sure that the packet's length is no greater than the datagram's length was missing from the code. And that allowed a large packet to overflow a buffer in a classic remotely supplied buffer overrun attack, which could be leveraged into a remote code execution, basically very trivially. Now, the good news is last summer, Steam independently, or Valve rather, independently separate from this, added to the Steam system ASLR, Address Space Layout Randomization, which from that point on would have made exploiting this much more difficult. Not impossible, because we've seen various ASLR bypasses which can be done, but it's much more difficult. Anyway, just another example of how long-standing protocols can have errors. They're kind of a little suspicious sometimes. I mean, like the test for successive UDP fragments is there, but not the test for the first one. It's like, okay, well, there is a different code path for the first fragment in a series of them, so you could explain it that way. But of course, what you always wonder for a problem this simple to implement. I mean, like, this is way easier than Heartbleed, that you didn't know maybe you were going to get data from a server or not. I mean, that was, a very low probability key extraction, and the world had a meltdown over it. Here, you just send a malformed UDP packet to any of 15 million Steam clients, and you're running code under the rights of the Steam client.
That's
which
terrible.
is,
That's terrible.
it is. Yeah. And so it's been there for a decade. And so you have to wonder, did anybody else ever know about this? And, was it used? The good news is it won't be any longer. And to Valve's credit, they fixed it immediately, like within hours of being informed. So credit to them. And yes, everybody can make a mistake.
The scary thing about this is that Steam, typically on a Windows PC, is running all the time. Once you install it, it's just sitting there in the system tray. It's not one of those things you run it and then close it. Yeah.
Yeah. So it's like having your own little, open vulnerability on the internet, unfortunately.
Yeah.
Speaking of open vulnerabilities on the internet, it turns out we talked a couple weeks ago about these Redis servers, Redis.
Redis. We use Redis, actually.
Redis, okay. Yeah. They are RAM-based indexed data stores, which are, they're very cool. They are used
caching.
Normally. Yes, exactly. It is sort of a big index meant to be used on an internal intranet, never meant to be exposed to the internet. That is, it's not a web server where it makes any sense at all for it to be publicly exposed. It's meant as an internal cache. As a consequence, there is, believe it or not, the default installation. Well, I mean, yeah, it is believable. The default installation assumes that position, that is a non-publicly exposed position. So there is no network or authentication security enabled by default. They are wide open. So naturally, in the world that we have, rather than the world that we want, although it was never their designers' intent, many thousands of these servers, and actually somewhere around 72,000 of them, to give it a number, are sitting happily out on the public internet for anyone to horse around with, even though not one of them should be. Okay, so Imperva Security, whom we've spoken of often, they're an active internet security, network-based security firm. They've been running a network of honeypot servers, of Redis honeypot servers, in order to observe and characterize the behavior of the attacks which are coming against them. As a consequence of their honeypots, they've discovered that these servers have the SSH, the secure shell authentication keys, installed so that persistent future access could be obtained if the servers were ever to be secured in the future. That is, if they're not taken off the public internet, but if someone goes, oh my goodness, we've got malware in our Redis server, let's add authentication so that not anybody, so that no one can make an unauthenticated access. Well, so what's happened is the bad guys have already taken advantage of their access to install persistent SSH keys so that presumably they'll be able to telnet in with authentication that they have provided for themselves. So hopefully anybody, if the security of these servers ever comes on the radar of people for whom it already should be, they'll just wipe and reinstall. They're RAM-based servers, so there's really no reason not to just clean them up and bring them back up on the intranet without any public exposure. They should not be exposed publicly. Anyway, so it's funny, as I was thinking about this, I'm just struck by how bizarre today's internet, how bizarre today's climate feels. Leo, like just 10 years ago, during this podcast, when the podcast was almost 3 years old, because we're coming up now on the end of our 12th year, this was the stuff of science fiction. If this kind of problem didn't exist. But here we are now, episode 666 of Security Now, and it's just like, oh, well, just another episode. Unbelievable.
Oh, I can't imagine what's going to be like at 999.
Oh, boy. Okay, so Chrome 67, they did, as Google always does, moving things forward. One of the things that they moved backward was just with like a day or two ago, I think it was late last week, was the removal of one of the experiments, because not all of their experiments fly, as we know. They do stuff. They see how they go. Sometimes they stick, sometimes not. This one did not stick. HPKP, HTTP-based public key pinning. So the idea was kind of cool, but it never happened. In fact, the number I saw somewhere was 0.04% of websites ever tried this. So the idea was that a web server with HTTPS security, so a standard SSL, now TLS security certificate having a public key, could publish the public key in its response headers to browsers. And it would be saying, this is my public key. Sort of formally, the browser would store it, and thus any future visits where a connection was established with a server, if the browser had previously received a declaration of the server's public key, it would re-verify the public key declaration with the public key now just received from the server. And we call that key pinning. The key would be pinned in the browser or by the browser so that if the public key did not match, the connection would be denied. So the point is, this only makes sense if you rigorously enforce it. That is, if a site has said proudly, here's my public key, and the only reason it's saying that is it wants the security of HPKP, HTTP-based public key pinning, of anyone who might spoof it to be denied. So, because there's no way, there are, as we know, if certificates are misissued, like, WoSign or Komodo or one of these sort of sketchy CAs were to issue a certificate for the domain that they should not issue it for, the certificate would be valid, but the public key would be different. So, and there's no way for a third party to copy the public key, because that's based on the private key that hopefully never does leave the server. So you can create a duplicate certificate that is valid for the same domain. You can never duplicate the public key. Now, of course, the problem is there are many ways this could go wrong. If a bad guy somehow intercepted your connections, like with a DNS spoofing attack, or somehow arranged to get an invalid public key pinned in browsers, then that browser would never accept the valid connection from the website. I mean, the idea is this public key pinning only works if the valid public key is what gets pinned. If there's any way for a malicious one to get pinned, you're in trouble. And we also know that sometimes websites are surprised by the expiration of their SSL certificates or their TLS certificates. From time to time, people will say, you'll go to a website and get the notice that the certificate is expired. Well, not only are the website's visitors surprised, but the website's administrators are scrambling around like crazy trying to get a new certificate issued. The problem is that new certificate will have a different public key because it's a new certificate. And if they had previously pinned the expired certificate, now they're in trouble because they can't use the expired certificate's public key in order to update the PIN that the browsers have previously obtained. So the point is, the only way to use this safely is to use it very responsibly. And people who understood the risk just weighed that versus the benefits and said, no thanks. So it didn't happen. Consequently, no adoption rate, and it's been removed from from version 67 of Chrome. And I meant to look to see whether Firefox ever even supported it. It may not have ever gotten off the ground beyond Chrome and Chromium-based browsers. So anyway, now it never will. All of this is my introduction to the topic that we will end the podcast with, which is certificate transparency. In Google's own coverage of this, when they talked about this, they announced it as in their developers.google.com. They said deprecate HTTP-based public key pinning. They said HTTP-based public key pinning was intended to allow websites to send an HTTP header that pins one or more of the public keys present in the site's certificate chain. But and then they said it has very low adoption, and although it provides security against certificate misissuance, it also creates risks of denial of service and hostile pinning. So anyway, they said to defend against certificate misissuance, web developers should use the expect CT header. And we now know that CT stands for certificate transparency. So there is a new header, expect CT. And they said, including its reporting function. They wrote, expect CT is safer than HPKP due to the flexibility it gives site operators to recover from configuration errors, and due to the built-in support offered by a number of certificate authorities, and we'll be talking about that in a moment. I did want to just note the final availability, and I know you've been talking about this, Leo, of Intel's previously known as Crosspoint, but officially trademarked as Optane memory.
We were all excited. Remember when we heard about Crosspoint?
Yeah. It's exciting because, just to remind our listeners or to inform those who don't know, that it's an incredibly dense, very high speed memory, non-volatile like flash, but if you can imagine a grid of conductors on the bottom layer, and then a grid of another grid at a 90-degree angle to them, so that you form a bunch of intersections between the grid points, and there you put a little blob of goo, to be unscientific. This blob of goo has memory. So unlike flash memory, where it depends upon stranding some electrons to create an electrostatic charge that can influence a metal oxide semiconductor gate, this actually is a state change technology where a previous zap of current permanently alters the state so that the resistivity of that intersection changes. The reason it's exciting is that it is non-volatile and 4 times the density of DRAM. Dynamic RAM, which is what we have now, has previously been the most dense storage technology we have, but of course it is famously volatile, which is why we have hard drives and we've got caches that are faster. DRAM is just persistently slow. So it's going to be interesting to see how this changes the architecture of computing over time. I mean, it's a game-changing technology. You can buy Optane SSDs on Amazon right now. They're not that expensive, and there are some things that look like DIMMs, which are like 512 gigs, so half a terabyte of Optane memory for particular applications. I think what this is going to do is it's going to change the way computer systems are structured, because it has such a different set of speed and performance characteristics, and our existing, DRAM or hard drive to DRAM to 3 layers of caching to processor core to registers in the processor. All of this kind of changes, so it's going to be interesting to see how it evolves over time.
Yeah,
it's not clear.
Exciting. I mean,
yeah,
we'll see what
we
happens.
don't often see this kind of a major potential changing technology hit our industry.
Yeah, I've been waiting for a laptop with Optane and an i9, but they're coming.
Yeah,
I was hoping for a Mac.
I got an interesting note from a Gary Ford, F-O-A-R-D, I guess that's how you pronounce his name, in England on the 1st of June. He said, "Hi, Steve. I'm a big fan of your show and a happy Spinrite owner. However, as your next episode is 666, so he wrote this last week, I think it is time to ask my awkward question." He said, "I recently stumbled upon an old screenshot of Norton's Disk Doctor, and I was surprised to see how similar one of the screen images look compared to the main graphic status display of Spinrite. He says, although I followed your Security Now show for many years now, he says, I don't really know what your personal background, timeline, progression, education is. All I know is I see a sincere, experienced IT chap who does, and he has an acronym here, GAS, and he says, parens, give a shit, as you once said. And he says, I guess that's why we all keep listening. So to his question, he says, did you work for or with Norton at some point? Did DOS-based graphics dictate the identical look or something else? Regards, Gary Ford. And I don't know if I've ever talked about this, but unfortunately, I refused to sell Spinrite to Norton after a lunch that Peter and I had, where he wanted to buy it. Spinrite was only about 2 years old at that point, and he said over lunch that it was the number one thing that the purchasers of the Norton utilities wanted was Spinrite. And he said, so we're going to buy it. And I said, gee, Peter, I'm very flattered. But, maybe when Spinrite is in its, waning years, that would make sense. But, it's brand new and it hasn't even, I'm not finished with it yet. And it's my bread and butter. And I don't want to sell it to you. And so he said, no, really, name your price. And I said, there's no price, really. I mean, except an insane price that, you would never consider. So thanks for lunch, but no. And so we went back up to their offices in Santa Monica and met someone who was the CEO of Norton at that time. Peter he didn't want to manage the company. He'd sort of stepped aside from management. There was someone named Ron Posner who
I remember him.
Yeah. Not a good person.
No.
And so Peter and I walk in, and he's to evil Ron Posner's office, and he said, so we have a deal? And it really, I will never forget the look on Peter Norton's face, because it looked like sort of like the dog that had been caught doing something bad, like, digging up the flower bed or something. I mean, he really looked kind of sheepish, and he said, no. And Posner said, what do you mean no? And Peter said, well, Steve doesn't want to sell. And Posner, I don't remember the details now. I mean, I wasn't happy either. It was all kind of awkward. But I just said, I'm sorry, but no. So maybe, I'm not sure exactly what the timing was, but it was around the era of Spinrite 3, or I was working on it or something. And there was another guy, John Goodman, who actually wrote a book about Spinrite. There's a Spinrite book.
Really? I didn't know that.
It got written. And in the process, he was covering other hard disk utilities. And he interviewed someone who explained why it was that what they created, which was called the Norton Disk Doctor, looked identical. What Ron Posner reportedly did was hand a copy of Spinrite to one of their developers and say, go home, stay home until we have our own version of this. And what really upset some of my developers, some of my people, was that it annoyed me too, was there were some functions in the BIOS where support was not guaranteed. And in my code, I was testing for the presence of the functions by putting some arbitrary data into the registers and calling the function to see if the function modified the data. We looked inside Norton's Disk Doctor, and they had copied the code verbatim.
Wow.
So, yeah. So
did you go after him?
No, because
where'd they get the
nature.
code? Did they reverse engineer it?
Yeah, they disassembled Spinrite, and what was sad was that they didn't even innovate the screens. I mean, it looked like Spinrite. I mean, I know exactly what Gary, who wrote this email, said, because everyone in the industry at the time assumed I had sold Spinrite to Norton. Wow. And the good news was they ended up abandoning it because since they hadn't actually written it, they couldn't support it. And we ended up, their own tech support ended up sending their Norton Utilities customers to us because they
that's nervy.
They needed help. And so we would say, oh, well, we understand you have a problem. Buy a copy of Spinrite, because we're actually the people who wrote, apparently, what you've got from Norton, and then we'll be happy to support you. Fix your drive and answer your problems. So, yeah, that's the story of Norton Disk Doctor, as far as I know, from third-hand reports. But from first-hand knowledge, there was absolutely my code in their product because they didn't know why I had put those random numbers or those particular numbers in the registers to call the BIOS. And so they didn't dare change them. So it's like, wow, okay. Yeah. And I had some employees who absolutely wanted me to sue them, but I was a little guy and they were, Norton, and it's like, and you end up in court forever, and it's like, no, thanks. And they were unable, it had no future. Now, Spinrite's still going strong. So it's like, it was the best decision I ever made not to sell it to Peter. I mean, he would have paid me a couple, $100,000 back then or something. It's like, no, thank you. So the right decision made.
Fascinating story. Wow. You want to take a break?
Let's do our last break, and then introduction to certificate transparency.
Yay.
But first, a word from IT Pro TV. We talk about them all the time. In fact, I know there are a huge number of IT Pro TV customers who listen or watch Security Now, because when we were at the IT Pro TV launch of their brand new studios, they all said to say hi to you, Steve. Like hundreds of people. Tell Steve hi. IT Pro TV, of course, there's a natural connection. IT Pro TV is the place to go if you want to get a job in IT, place to learn the skills you need to take the exams, to get the certs that anybody entering IT needs to have to prove you know the stuff. And of course, if you're in IT, IT Pro TV is a great place to keep those skills up to date and learn new skills so you can get a better job or more pay in your existing job. Learn the skills to pass the most in-demand IT tests from CompTIA to Cisco, EC Council. That's the Certified Ethical Hacker cert, my favorite. VMware. Everything. Windows, Macintosh, IT Pro TV has you covered. They now have over 4,000 hours of binge-worthy on-demand training. When I say binge-worthy, I mean you'll want to binge it. It's fun, and it's easy, too, because you can stream it to a Roku, an Apple TV, your Fire Stick, your iOS or Android device, your computer. So you can watch it live or on demand. There's always new content. They do 125 live hours a week. A week! So you'll always be up to date. And if you have a team, an IT team that you want to keep up to date, this is a great thing to get for your IT team. You got to check out their Pro Portal. You can gain full control over your team's training schedule, track their results, check their logins, assign training. That's the Pro Portal. You'll see metrics like logins, viewing time, courses viewed, tracks completed, and more. It's a great way. A lot of companies, a lot of universities have purchased this Pro Portal so they can keep their IT department up to speed. Now more than 100,000 members at IT Pro TV. That is great. So here's the deal. You want to know more? I'm sure you do. itpro.tv/securitynow. You can find out about their team solution, the Pro Portal, and request a trial. That's free. If you're an individual, you can also get a free deal, a week free, at itpro.tv/securitynow. And when you use the code SN30, you'll get 30% off your subscription for the lifetime of your active subscription. So just as an example, they have standard and premium subscriptions. A premium subscription, which is really a great deal. You get the virtual server, so you can use any HTML5 browser to configure Windows servers and clients and, break stuff. Just close the tab. That's what I do. It's really a great way to learn. They also have unlimited Kaplan IT training practice exams. Those are great too because you can take the exam before you take the exam. Those used to be called the Transcender exams. All of that normally be $857 a year, which I think is, compare that to the cost of a technical school. That's a great price. But use the offer code SN30 and you cut that down to $600. This is the premium plan for less than $50 a month. That is a great deal. itpro.tv/securitynow. This is a training that'll pay for itself overnight, practically, with a better job or your first job in IT. itpro.tv/securitynow. Flexible training, binge-worthy content, life-changing results. Don't forget to use the code SN30. All right, Steve, it's time to learn about our subject of the day.
Okay, so we have talked throughout the history of this podcast about the way this certificate authority system functions. We have once upon a time, a handful of certificate authorities who were responsible and trustworthy. And their public key is contained in our so-called root store in our computer. And a website asks them, proves the ownership over the domain, twit.tv, grc.com, whatever. And so the trusted certificate authority uses their private key to sign the certificate, which, it is like a certificate. It says, we certify that the holder of this certificate is the owner of this domain. So they use their private key to make that assertion, and then that certificate is what the website sends when you connect to it, saying, you're really connecting to us. And so it has two functions. It authenticates the other endpoint, and as part of the negotiation with TLS, it provides both authentication and privacy thanks to encryption. So keys are negotiated and so forth. But the key part of what the certificate's doing is it's a self-expiring assertion of ownership of a domain. And if everything worked like that, then we'd have no problems. But there are problems with it. First of all, there are no longer a handful of certificate authorities. There's a gazillion of them. That's the technical term. And among them, are many that have unfortunately misbehaved, in some cases deliberately. Was it TrustWave? I think it was TrustWave that deliberately issued an intermediate certificate so that a customer of its could mint certificates on the fly for a middleware box. That was the story. I'm still suspicious that was the case, but they got caught, and as a consequence, that certificate was revoked. Normally, a middle box like that, like a corporation has on their network, requires that all of the clients receive its own certificate, so that they're trusting things signed by that box because they're inside the network, not like all browsers in the world trusting all certificates signed by everyone. This is the problem that we have, is that as the number of certificates has exploded, we have to our root stores, which used to have a few public keys, have to have the public keys of all certificates that we might, the public keys for the signatures of all the certificates that we might encounter. So the system didn't really scale that well. So there's the misissuance problem, there's fraudulent issuance problem, and then of course there's also the revocation problem that we've talked about, where no one could have made a malicious mistake, but due to a mistake made by the holder of the certificate, or the private key that goes with that certificate, that could escape, and they would then need to revoke the credentials of the certificate that had been signed. So through the years, there have been different attempts to solve this problem. We were talking earlier about HPKP and how that was an attempt to do public key pinning. That never really worked. And Chrome has had that CRL set where it's kind of revocation, but it prioritizes only the certificates that they feel are important enough. Maybe those are the EA certificates, but not OV and I mean the EV certificates, and not OV or DV, not the organization or the domain validation certificates, and so forth. And then there's the OCSP, the online certificate status protocol, and so forth. So this has been an ongoing problem. About 4 years ago, Google came up with another solution, and it's gaining traction, or I should say it's gained traction rather quietly. And it's a nifty idea. It is going to still take some time to go from advisory to sort of like advisory status to enforcement status, because it does require all certificate authorities to participate for it to work. In the same way that all certificate authorities have to have their root certificate in the store, although in this case, participation is probably a little more involved than that. Okay, so what is it? Quite simply, it's a public log. It is a special cryptographically secured append-only log of certificates which are issued. And it's called certificate transparency because this public log intends to make the issuing of certificates be transparent. Right now, if random certificate authority XYZ issues a cert, nobody knows. I mean, it's a transaction between the domain holder and their CA, who they have chosen to pay for the signing of a certificate, and that signature is trusted by everybody's browser in the world. So it's a quiet transaction. Notice that one of the things we've talked about is how the Chrome browser's ability to know if the Google certificates were valid gave it a lot of leverage. That is, over the years, there have been a number of instances where somebody somehow got a non-authentic Google property like google.com certificate, and a user of Chrome went to a site that was spoofing Google, and instantaneously the jig was up. Chrome does have pinning for the Google property certificates, and so if anybody tries to pull a google.com certificate that isn't valid on a Chrome user, that the Chrome browser instantly phones home to Google and says, whoa, we just received a certificate that should not exist in the wild. And so as a consequence of Chrome's dominance and Google's special position in the world, there has been this particular closed loop. So certificate transparency is sort of an effort to extend that model globally. There are three components to the CT system. There's a certificate log, then there are certificate monitors for the logs, and there are certificate auditors. And I should mention that there's a site where all this is explained. It's www.certificate-transparency.org is where this stuff lives. Everything is open and open source, and this is another significantly useful effort which Google has created and is helping to manage and run, and it seems to me like it's the future. Google writes, as they're explaining it, about the logs, the monitors, and the auditors. They say these functional components represent discrete software modules that provide supplemental monitoring and auditing services. They are not a replacement for or an alternative to the current SSL certificate system. In other words, all of that stays in place. This is a means of watching the certificate authority system operate and catching mistakes. Google continues saying, indeed, these components do not change the fundamental chain of trust model that lets clients validate a domain and establish a secure connection with a server. Instead, these components augment the chain of trust model by providing support for public oversight and scrutiny of the entire SSL certificate system. And that's why this is so cool. So they say under basic log features, they say at the center of the certificate transparency system are certificate logs. A certificate log is a network service that maintains a record of SSL certificates. Certificate logs have three important qualities. First, they are append only. Certificates can only be added to a log. Certificates cannot be deleted, modified, or retroactively inserted into a log. They are cryptographically assured. Logs use a cryptographic mechanism known as Merkle tree hashes to prevent tampering and misbehavior. And finally, they're publicly auditable. Anyone can query a log and verify that it's well behaved, or verify that an SSL certificate has been legitimately appended to the log. So, and they say the number of logs does not need to be large. There need to be enough logs so that log failures or temporary outages are not a problem, but not so many that they become difficult to monitor. And Google says, say more than 10, but much less than 1,000. Each log operates independently of the other logs, which is to say there's no automatic replication among the logs. And they said the append-only nature of a log allows it to use a special type of cryptographic hash to prove that it's not corrupt and that the log operator has not deleted or modified any certificates in the log. This special hash, they write, known as a Merkle tree hash, also makes it possible for auditors to detect whether someone has forked a log or inserted backdated certificates into a log. And it's funny, too, because at some point, as I was reading into this, I don't remember now where it was some time ago, but the author of what I was writing said, and yes, it's inevitable that this is going to be compared to the blockchain or a blockchain or some blockchain, and that's not what it is. So however, of course, the reason it's sort of subject to comparison is that it's got some of those sorts of features, a publicly auditable, non-modifiable thing, although it doesn't work the way a blockchain does, and it is a standalone append-only data construction that I imagine we will talk about at some point in the future. And what I got a kick out of it, what was significant to me also, as I mentioned at the top of the show, is my favorite certificate authority, DigiCert, was the first CA to get themselves going with a certificate transparency log. Since then, and that was February 1st of 2015, so more than 3 years ago, other CAs have been establishing logs. There is a Let's Encrypt log, and the idea is that there is a JSON, JSON, a computer readable list of logs, which allows CAs to publish the announcements of certificates that they're issuing in the log. And so as I said at the top, once upon a time, there was no knowledge of the issuance of a certificate until it appeared being received in a browser by someone going to a site that was asserting that certificate. This provides a repository of certificate issuance transactions over time, which is publicly available, cannot be altered after the fact, and once the system has moved from the reporting stage to the enforcement stage sort of solves this problem of needing to of the system not having sort of a like closed loop feedback into the issuing process. This closes the loop, providing a declaration of that it can be machine searched quickly in order to determine what the status of any domain certificate is. So I don't want to go into any further detail at this point. We are out of time for one thing, but I imagine as this continues to gain traction, we'll be coming back and talking about some of the very cool underlying technologies of the certificate transparency system. I've touched on the topic, just used the term a few times, but never really established what it is. So I thought with the opportunity of Chrome 67 removing another attempt at solving this problem, talking about the right way, the way that is clearly gaining traction and looks like it's going to win, is worth discussing. So now we have.
You bet it is. Thank you, Steve. Always interesting. I learn so much, and I understand so little. Steve does this show, and I'm here for the ride, every Tuesday about 1:30 Pacific, 4:30 Eastern, 20:30 UTC. If you want to tune in live and watch us live, you can be in the chat room at irc.twit.tv. Nice bunch of people in there. And you can also be in the studio. We had a lovely family here from St. Louis. Alan, Whitney, and Bennett were visiting. One of the three's eyes weren't glazed over. 1.5. But they made it. They survived. They got through it. Actually, Alan does security at a bank, IT security. So I think he understands what we're talking about. If you want to be in studio, you can just email tickets@twit.tv. You can also watch live on the stream at twit.tv/live. On-demand versions of the show available from Steve at grc.com. That's his website. That's where you find the software even Peter Norton couldn't buy.
The original.
But you can,
real.
For a lot less. grc.com is the home of Spinrite, world's finest hard drive maintenance and recovery utility. And proudly written in assembly since 1984. When did you first write it?
I think that's right. It was the late 80s, yeah.
Wow. It's still going strong.
Because I bought my home in 84, because that's, of course, George Orwell's book. And Spinrite was a couple years later, so like 86.
Nice. grc.com. There's lots of other good stuff there, too. This podcast, handwritten, human-composed transcriptions, which actually are great because it helps you if you want to search for a bit of the show. You can search the text, then jump to that part of the audio. We have video as well as audio at twit.tv/SN. All our shows are here on demand, and you can always find any show we do on your favorite podcast application. Just subscribe. That way it'll be in your inbox the minute it's available. Tuesday evenings, thereabouts. Thank you, Steve, and we'll see you next week on Security Now.
Thank you, my friend. See you then.
Security.